Example 3 is asking us to do many of the same things, but this time as you look at the directions, you're going to see that the question is asking us to finalize our answer by writing our solution in interval notation. So let's go ahead and check out part A. For part A, we have negative 16 is less than 3n minus 5, which is less than or equal to 13. So let's talk about this as a general idea first, and then go ahead and talk about the solution process. So thinking back to something we talked about earlier, this is an example of a three-part inequality. We have a piece over here, a piece in the middle, and a piece over here. So that means that our 3n minus 5s are between negative 16 and positive 13. Now, the reason I like to call this a three-part inequality is that it gives me an idea of how to move forward with the solution process. So when I think about equations, whatever I do to the left-hand side, I need to do the same thing to the right-hand side. If I have a three-part inequality, whatever I do once, I have to do 3 times. So keep that in mind as we move forward. So let's check out how to think about this in terms of many of the same ideas we did with equations. So start by focusing your attention on the part of your three-part inequality that involves the variables. So the part that involves the variables in this case is the middle part. And as I look at that middle part, my goal here is to solve, which means I want to get the n alone. In order to do that n alone, I need to add 5 here. But once again, because this is a three-part inequality, if I add 5 once, I have to do it 3 times. So I add 5 to the middle part, but I also have to add 5 to the right and add 5 to the left. So notice I'm adding 5 3 times. Well, let's see what happens when I do that. Negative 16 plus 5, be careful with your signs, be careful with the idea that we have one negative and one positive here. Negative 16 plus 5 is going to be negative 11. And we have less than, here the 5s are going to cancel, leaving us with 3n, and over here we have 13 plus 5, that's going to be 18. Next off then, again, focus your attention on the part that has the variable, middle part there. The 3 and the n are connected by multiplication. And because they're connected by multiplication, I need to divide by 3. Now, because we're in equation land, because we're in inequality land, I need to be careful about dividing by things. If I divide by a negative, I remember that I have to flip all my inequality symbols. So I always have to ask that question, did I divide by a negative number? In this case, the answer is no. And because the answer is no, I don't have to worry about flipping inequality symbols. But if I did, I would. So let's keep going. Three-part inequality, if I do it once, I have to do it 3 times. Divide the middle part by 3, divide the left and the right-hand side by 3 as well. So now that we have all those 3's in there, I need to come in and simplify where I can. On the left-hand side, 11 and 3, I can't do any kind of simplification there, so this is simply going to be a fraction, negative 11 thirds. Middle part, the 3's cancel, leaving us with an n. And then on the right-hand side, this time I can do some simplification. 18 divided by 3 is going to be 6. So we have less than or equal to 6. So now that I have this then, I have an answer as an inequality. But again, inequalities will never be a final answer in this section. So this problem, one more time, said, go ahead and write your answer in interval notation. So as you look at this as an inequality, in order to write it in interval notation, some people can go directly from the inequality to interval notation, and if you can, great. But if you have any problems with it, you can always go ahead and put in an extra step. Even though the problem didn't ask for a graph, you can graph this, and if the graph is helpful to you to write down your answer in interval notation, feel free to go ahead and do it. So I'm going to go up here to the top and think about the fact that I have n's here, so I'm going to put an n on my number line. And negative 11 thirds has to be over on the left-hand side, and positive 6 has to be on the right-hand side. Because this is a three-part inequality, I'm going to color in everything between these two numbers. I'm not going to include the negative 11 thirds, but I am going to include the positive 6. So now that I have that picture, I can write down the interval notation for this. Left to right, I start off with a parenthesis and a negative 11 thirds. Again, I'm using the parenthesis because I'm not including that negative 11 thirds. And then as I move to the right, the last number that I encounter here is a 6. And because of that solid dot, I'll put a square bracket. So there's our final answer in interval notation. Now that we have that, we're ready for part B. So you'll start off by writing down part B. It's 3 times the quantity x plus 1 is greater than 3x plus 2. Once again, I'm going to notice that this has a lot of the same flavors as the problem we just looked at, and a lot of same flavors as equations we saw earlier. So 3 times the quantity, distribute. We're going to get 3x plus 3 is greater than 3x plus 2. I want to start by getting my x terms together on one side. That means I'm going to subtract 3x from both sides. Left-hand side, the x's cancel, leaving me with a 3. Right-hand side, the x's cancel, leaving me with a 2. Well, once again, be careful not to put pieces into this inequality that aren't there. This is not x is greater than 2. This is not x is less than 3. This is 3 is greater than 2. So once again, when you get to one of those inequalities where you have a constant on both the left-hand side and the right-hand side, you have to do some interpretation. Now, we saw a moment ago in example 2 that we had an example where things ended up at an inequality that was never true. That's not the case here. 3 greater than 2 is in fact always true. So that means this problem is different than the one we were looking at a moment ago. So now the question is, what does that mean in terms of our answer? If 3 greater than 2 is always true, that means that our original inequality is always true as well. Well, let's think about what that means then. So if I think about it graphically, and I have my x values here, is this going to be true if I have an x value of 7? Sure, because 3 is greater than true is always true. Well, okay, would this be true if x was 14? Sure, because once again, it doesn't really matter on the x. Is 3 greater than 2? Yeah. If it's greater than 2 when x is 14? Sure. So 3 is always greater than 2. So I can keep doing this on every x value out there. No matter what my x value is, 3 is always going to be greater than 2. So because of that then, I have the entire number line colored in. And this problem is asking us to write down the answer in terms of interval notation. We saw this on the front side of the handout. Interval notation way of saying everybody would be the parenthesis, negative infinity, comma, infinity, parenthesis. So there's our answer, all real numbers in interval notation.